So in this video, we are going to start a new chapter, chapter number 6. It's called lines and angles. So in this chapter, in this whole chapter, not in this video, in this whole chapter, we are going to study properties of angles when, okay, we are going to study properties of angles when, case number 1, two lines intersect each other, okay. What does this mean? Take any two random lines. Let's say I'm going to take this, okay, let's use the line. So this is my first line, line number 1, and then this is my second line, line number 2. Okay, so properties of angles when two lines intersect each other. So when these two lines have intersected each other, we can see that there are four angles that are formed: 1, 2, 3, and 4. Okay, so in this chapter we will study properties of angles, these four angles, when two lines intersect each other. That is the first thing. And the second thing is, yes, the second thing is one line intersects two parallel lines. Okay, how does it look diagrammatically? So first I will draw two parallel lines. So this is parallel line 1, parallel line 2. Okay, these arrows are important. And then one line is going to intersect two parallel lines. So let me draw this one line which intersects two parallel lines. Okay, once again note the angles that are formed. Okay, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so once again we are going to see properties of angles when one line intersects two parallel lines. When one line intersects two parallel lines, okay, this arrow, yeah, that time we get we get 8 angles, and we're going to see properties of these 8 angles. So this whole chapter, not this just this video, this is an introductory video, but this whole chapter, chapter number 6, is going to be about studying these angles which are formed, okay, by the lines. Hence the name of the chapter, lines and angles. Okay, now that it's clear that what the chapter is going to be about and what this entire chapter series is going to be about, let's start with some basic terms and definitions. Okay, one by one we'll see some basic terms and definitions in order to get us started with the actual lines and angles of the chapter. So the definition, the first definition or the first term is line segment. Okay, so let's see the definition. Okay, what is a line segment? A line, okay, a line with two endpoints is called as a line segment. So again, very quickly, let us draw, let us do a diagrammatic representation. This is a line with two endpoints. So these endpoints are important. Okay, a normal line is like this, which doesn't have an endpoint. It will always have an arrow which indicates that the line is infinite. Okay, so this is a line. Let me write it down. This is a line, but this thing, it's a line segment. Okay, so a line segment is a line with two endpoints, so it ends here. Okay, it's not an infinite line on both the sides. So that's a definition of line segment. Let's move ahead. The next definition is ray. Yes, so what is a ray? Let's check it out. So a ray is a line with one endpoint. Okay, so once again, this is a line. Okay, line has two, the line has zero endpoints, so both these are infinite arrows. Okay, a line segment will have two endpoints, so this is a line segment, whereas ray is the one which has only one endpoint. So this is one endpoint of the ray and the other one is going to be an arrow. Okay, so in order to avoid the confusion, let's erase this. Yes, so this is the diagrammatic representation or understanding of a ray. It's a line with one, this is the endpoint, and this is the arrow which shows an infinite extension. So that's a ray. Now the next definition is collinear points. What are collinear points? So once again, let's remove this. Okay, so collinear points definition: if three or more points lie on the same line, then they're called as collinear points. Why three and more? If I give you 2 points, any 2 points are always on line. Okay, if I give you this point and this point, they're always on one line. In fact, the definition of line itself is something which needs 2 points. So when you give any 2 points, there always will be a line that exists which will connect or which will lie on both the points. Now, if we give three or more points, which lie on the same line, then those 3 points become collinear. Okay, for example, let's erase this. Okay, now let's take this point number 1, point number 2, and let's take this point number 3. So can we have a line connecting all these three? No. We have to take this one line and this one line. There are two lines which will connect the 3 points. So if you want the 3 points on one line, they have to be like this. Okay. So only in this case we say that these 3 points are collinear because they lie on the same line. These 3 points are not collinear because they lie on two different line segments. This is one line and this is one line. Okay, so this is the definition of collinear points. Let's remove this. Yeah. Now going ahead, we have to see the definition of angle. What is an angle? Because remember the chapter name is lines and angles. So we saw different types of lines, line segment, ray, and collinear points. Now let's see what an angle consists of. So once again, let's remove this. Yeah. So when two rays originate from the same endpoint, that's called an angle. Quite simple. So we have seen what is the definition of a ray. This is our definition of a ray. Okay, this is our definition of ray. So here they are saying that we need two rays which originate from the same endpoint. Okay, so for example, this is my ray number 1 and this is my ray number 2, but these two rays are originating from different endpoints. When they have the same endpoint, okay, let's say this is my ray number 1 and this is my ray number 2. So I'm just going to write here, this is my ray number 1 and this is my ray number 2. So when two rays originate, so both of them originate from the same endpoint, that's called an angle. Quite simple and straightforward definition. So this thing is called as an angle. That is the definition of an angle. So once again, let's erase this and keep the actual diagrammatic representation. Okay. Now in terms of angle, we have lots and lots of different types of angle based on their measure, based on the way they interact or intersect with each other. So we're going to see each and every type of angle that exists, which will help us to further study this chapter of lines and angles. So let's start with quite simple and let's start with quite simple and obvious definitions of types of angles based on their measure. So first one is going to be an acute angle. So we all know what an acute angle is. Acute angle is angle which measures less than 90 degree. Okay, so the angle, let's say an angle x. So the measure of an angle, okay, is always between 0 degree, okay, 0 degree and 90 degree. Okay, for example, typically this is how the acute angle will look like. Okay, like this. So this x, which is the measure of an angle, okay, x is not an angle, x is the measure of an angle. So this x is always between 0 degree and 90 degree. Note, this is less than, okay, it is not less than or equal to, it is less than. So x has to be greater than 0 degree and less than 90 degree. Okay, now next type of angle is called right angle. So in right angle, the measure of an angle, okay, the measure of an angle x is exactly equal to 90 degree. So the way it looks is something like this. Okay, yes, so this is our right angle triangle whose measure is exactly equal to 90 degree. Okay, so that's called a right angle triangle. And then we can easily guess what is the next one. That's an obtuse angle. So an obtuse angle is an angle whose measure, so I'll say x is greater than 90 degree. Okay, x is greater than 90 degree and it has to be less than 180 degree. Okay, an angle whose measure is greater than 90 degree and less than 180 degree, it's called an obtuse angle. So diagrammatically it will look something like this. So yes, okay, so yeah, so here this x, okay, this is that x which is greater than 90 degree and less than 180 degree. So these are three very simple definitions of angle: acute angle, right angle, and obtuse angle based on the measure of an angle. So now moving ahead, we have next set of types of angle. The fourth one, you can say, It's called as a straight angle. What is a straight angle? Again, a very straight, simple definition. A straight angle is an angle whose measure is 180 degree. So it's something like this. It's in fact a line. So you can see this measure. Okay. Yes. So this thing. Okay. So the measure of this angle is going to be 180 degree. So if the measure of an angle is exactly 180 degree, then it is called as a straight angle. And it's also quite obvious because this angle is nothing but a straight line. Okay, so it's in fact a straight line whose measure is equal to 180 degree. Now next definition or next type of angle is called as a reflex angle. A reflex angle is angle whose measure is greater than, I'm going to write here, whose measure is greater than 180 degree. Okay, greater than 180 degree and less than 360 degree. Okay, for example, let's see how this will look like. Okay, let's say this is my angle. So you can clearly see this is one angle X. Okay, and at the same time this is another angle Y. Okay, this is another angle Y. So you can clearly see that the measure of this angle Y is greater than 180 degree and it's obviously less than 360 degree. So actually whenever you have this angle, so this angle will be an acute angle because it's less than 90 degree, and the opposite or the adjacent angle to this will be greater than 180 degree. So reflex angle is any angle whose measure is greater than 180 degree and less than 360 degree. So to quickly revise, we have seen 5 different types of angles based on their measure. Okay, here they are. Acute angle, it's less than 90 degree. Right angle is exactly equal to 90 degree. Obtuse angle greater than 90, less than 180. Then straight angle exactly equal to 180, and reflex angle greater than 180, less than 360 degree. So based on the measure of an angle, we have these 5 different types of angles. Now that is not the end of the story. We still have a lot of different types of angles to cover. So the next one that we have is called as complementary angles. Now this is not based on any measure of an angle, but in fact complementary angles are any two angles whose summation or whose sum is equal to 90 degree. Okay, so any two angles whose sum is equal to 90 degree, those two angles, that pair of angles, is called as complementary angle. Okay, for example, let me just say, for example, if I have angle A as equal to 30 degree, okay, angle B as equal to 60 degree, and angle C as equal to 50 degree, and angle D as equal to 40 degree. Okay, let's say I have something like this. Then in this case, then angle A and angle B, I will call them as complementary angles. Okay, I'm just writing it in short. And angle C and angle D are also another pair of complementary angles. Why are they called complementary angles? Because their sum is equal to 90 degree. The sum is equal to 90 degree. So A and C, 5 plus, yeah, A and C is summation is equal to 80 degrees, so they are not complementary angles. Or B and D summation is 100 degree, they are also not complementary angles. So that's a quick example of complementary angle. Now similar to complementary angle, we have supplementary angles. So what are supplementary angles? Let me draw a demarcation here. Yes. So what are supplementary angles? These are any two angles whose sum is equal to 180 degree. Okay. So conceptually they are very similar to this complementary angles, except that instead of 90 degree we will have 180 degree. Again note that this is a pair of angles, total two angles. A group of two angles will be called as supplementary angles if their summation is 180 degree. If we have just one angle whose measure is 180 degree, then that is not a supplementary angle. We need two angles, exactly two different angles whose summation will be 180 degree. That's an important point. Now if you think the types of angles are completed, then you're wrong. There are last two types of angles to be seen in this video, and The first one is called adjacent angle. So what are adjacent angles? So let us draw this. For example, okay, this is my one angle. Okay, is this an angle? Yes, because it is having a same, okay, it is having a common endpoint here. Okay, two rays which have a common endpoint is called an angle. So this is one angle. Now what I'm going to do is I'm going to, from this, okay, from the same common endpoint, I'm going to draw one more ray. Okay, now if you note at this angle, okay, let me give names. So let's call this as A, let's call this as B, let's call this as C, and let's call this as D. Okay, now there are two angles here in the picture. I'm going to note them down. So angle ABC and angle CBD. Okay, so now if you look at these two angles, angle ABC and, okay, so this is angle ABC and this is angle CBD. Now these two angles are called as adjacent angles because they have a common arm, and they have a common endpoint. Okay, very important point. I'm going to in fact note it down. So what's the thing that makes these two adjacent angles? They have a common arm, okay, common arm, and they have a common endpoint, and that is why these two angles, okay, ABC and CBD, will be called as adjacent angle. In fact, the word adjacent in English, it actually means neighbors. So you can clearly see that these two angles are neighbors to each other. The only reason being common, they have common endpoint and they have a common R. So that's the definition of adjacent angles. And now finally the last definition of, or the last type rather, in our angle series is called vertically opposite angles. What are vertically opposite angles? Again, quite simple and straightforward. I'm going to draw two lines. This is first line and this is my second line, and they are intersecting each other. Okay, now in this intersection we can see that this is one angle and this is one angle. They are vertically opposite to each other. Okay, this angle and this angle are opposite to each other. Similarly, this angle and this angle are opposite to each other. So this pair of angle are called as vertically opposite angles. In fact, let's give them names so that's easy to note down. This is, let's say this is A, B, C, D, and let's say this is O. Okay, so angle AOD and angle BOC, they are, I'm going to just write VOC, which means vertically opposite, sorry, VOA, vertically opposite angles. Similarly, angle AOB and angle DOC are also vertically opposite angles. Okay, so that is our final type of angle, vertically opposite angles. So in this video we saw a lot of different types of angles, and we also saw different definitions of line segment and collinear points. All these different types of angles and all these different definitions and terms of lines and ray and collinear points are going to be very useful throughout this chapter, because this chapter is all about different types of angles that we make in these two different cases. That's all.